people realized, GE, Westinghouse, Siemens, realized that there was a new type of technology called electricity, and new infrastructure has to be built all around the world. And these infrastructure became essential part of social infrastructure. That infrastructure is now called electricity. Years later, this is during all of our generation, we realized there was a new type of infrastructure. And this new infrastructure was very conceptual, very hard to understand. And this infrastructure called information. This information infrastructure, the first time it was described, made no sense to anybody. But we now realized it is the internet. And every internet is everywhere. And everything is connected. Well, there's a new infrastructure. This new infrastructure is built on top.
Hello everyone, Danny here, and welcome to the Pawn Pixel channel. Before we move on to the pulling Anaxagoras, let's watch some keynote first here. It's about the Infinia update, so that's it. Just watch together with me, and the part where I will draw the Anaxagoras, it will become after I done with all this streaming. Okay, thank you.
Every company all needs AI. AI has now part of infrastructure. And this infrastructure, just like the internet, just like electricity, needs factories.
I see.
And these factories are essentially what we build today. They're not data centers of the past, a $1 trillion industry providing information and storage, supporting all of our ERP systems and our employees.
They are talking about the AI,
data center,
right?
a data center of the past.
GPU
This
where
is
they evolve into the
similar in the sense that it came from the same industry.
AI infrastructure
it came from
or
all
something.
of us. But it's going to emerge as something completely different, completely separated from the world's data center. And these AI data centers, if you will, are improperly described. They are in fact AI factories. You apply energy to it, and it produces something incredibly valuable. And these things are called tokens. To the point where companies are starting to talk about how many tokens they produced last quarter and how many tokens they produced last month. Very soon, we'll be talking about how many tokens we produce every hour.
Every
just as
hour.
every single factory does. And so the world has fundamentally changed. We went from a company, on the day that we started our company, I was trying to figure out how big our opportunity was in 1993. And I came to the conclusion, NVIDIA's business opportunity was enormous. $300 million.
$300 million.
We're going to be rich.
Wow. I can gacha Anaxa too much
$300
with
million
that.
chip industry to a data center opportunity that represents about $1 trillion to now
Oh, let me
AI
check
factory,
another program
an AI
here.
infrastructure industry that will be measured in trillions
See
of
if that's
dollars.
doable or not.
And this is the exciting future that we're undertaking. Now, at its core, everything we do is founded on several important technologies. Of course, I talk about accelerated computing a great deal. I talk about AI a great deal. What makes NVIDIA really special is the fusion of these capabilities. And very especially, the algorithms, the libraries, what we call the CUDA-X libraries. We're talking about libraries all the time. And in fact, we're the only technology company in the world that talks about libraries nonstop.
Libraries.
And the reason for that is because libraries is at the core of everything that we do. Libraries is what started it all. And I'm going to show you a few new ones today.
Yes, correct.
But before
Library
I
is
do that,
important to help with
let me
your
show you a preview
development, correct.
of what I'm going to tell you today. Everything you're about to see is simulation, science, and artificial intelligence. Nothing you see here is art. It's all simulation. It just happens to be beautiful. Let's take a look.
Okay, so what's going to happen? We are doing some intermission, right? Who is come? Where TF? Where Star Rail? Where 7 TV? Oh my goodness. Are you asking for the emotion? 7 TV? Just wait a little minute, okay? Just wait a little minute. Let me add this 70v emote. Okay, this one. We just watch something side mission. We call it side mission first. Watch a bit and duration. Wait, default set. Wait. Hey, wait. Wait. Oh, I see. Let me check mark in this chat. Wait. 7 TV. Oh.
This is real-time computer graphics I'm standing in front of. This is not a video, this is computer graphics. It's generated by GeForce.
GeForce.
This is a brand
Is
new
that-
GeForce
Is that a new?
5060, RTX 5060. And this is from ASUS.
Oh,
good friend
5060.
Johnny's in the front
Okay,
row.
5060
And
graphic
this-
card. Okay.
This is from MSI. And we took this
7 TV, better TV,
incredible
frank
GPU
face.
and we shrunk it
Okay.
in here. Does that make any sense? See, this is incredible. And so this is MSI's new laptop with 5060 in it. GeForce brought CUDA to the world. Right now, what you're seeing is every single pixel is ray traced. How is that possible that we're able to simulate photon and deliver this kind of frame rate at this resolution?
Oh,
Well, the
I
reason for that is artificial
see.
intelligence.
Okay.
We are only rendering,
Authorize.
we're only rendering 1 out of 10 pixels. So every pixel
Wait a
that
minute,
you
bro.
see,
Wait a minute,
only
wait a minute.
1 out of 10 is
Chill,
actually
chill.
computed.
I'm set up your
The
emote
other
here.
9.
Don't worry.
AI guessed. Does that make any sense?
Okay.
And it's perfect. It's completely perfect. It guessed it perfectly. Of course, the technology is called DLSS, neural rendering. It took us many, many years to develop. We started.
Okay,
developing
can you
it the
try
moment we started working
emote
on
again?
AI,
Is
so
it
It's been a 10-year
working
journey.
right now,
and
or
the advance in computer graphics has been completely revolutionized by AI. GeForce brought AI to the world. Now AI came back and revolutionized GeForce. So really, really amazing. Ladies and gentlemen, GeForce.
OBS doc chat?
You know, when you're CEO, you have many children.
Yup. Everything already settled
And,
here.
and GeForce brought us here. And now all of our keynotes is 90% not GeForce. But it's not because we don't love GeForce. GeForce RTX 50 series just had its most successful launch ever, the fastest launch in our history. And PC gaming is now 30 years old. So that tells you something about how incredible GeForce is. Let's talk about libraries. At the core, of course, everything starts with CUDA. And by
I
making
see.
CUDA as performant as possible, as pervasive as possible, so that the
it should
install
be
base
appear in your
is
chat.
all over the world. Then applications can
7
find
TP
a
and more.
CUDA GPU quite easily. The larger the install base, the more developers want to create libraries.
Okay.
The more libraries, more amazing things are done,
Oh, I
better
see.
applications, more benefits to users. They buy more computers.
Enable.
The more computers, more
Better
CUDA.
TV, better
That
TV mode.
feedback
I also
path
enable
is
that.
vitally important. However,
Yep.
accelerated computing is
And
not
with that, it
general
should
purpose
be
computing.
working, right?
General purpose computing, write software, everybody writes it in, Python or C or C++, and you compile it. The methodology for general purpose computing is
Can
consistent
you
throughout.
try 70 VM mode?
Write the application, compile the application, run it on the CPU.
Or let me try.
However, that fundamentally doesn't work in accelerated computing, because if you could do that, it would be called a CPU. What's the
Is it
point
working?
of not just changing the CPU so you could have write the software, compile the software, run it on a CPU? The fact that you would have to do something different is actually quite sensible. And the reason for that is because so many people worked on general purpose computing, trillions of dollars of innovation. How is it possible that all of a sudden a few widgets inside a chip and all of a sudden computers become 50 times faster, 100 times faster? That
Yep.
makes no sense.
I think it's working.
And so the logic that we applied is that we could accelerate applications if you
dance.
understood more about it. You can accelerate applications if you were to create an architecture that are better suited to accelerate, to run at the speed of light, 99% of the runtime, and just even though it's only 5% of the code, which is quite surprising. Most applications, small parts of the code consumes
7
most of the
TV
runtime.
already
We made that
enabled,
observation, and so we
and
went
better
after
TV
one
also
domain after another.
enabled, so
I just showed you
both-
computer graphics.
both already
We also have
enabled.
numerics. This is CuPy numeric. This is CuPy is the most pervasive numerical library. Arial and Shona. Arial is the world's first GPU accelerated radio signal processing for 5G and 6G. Once we make it software defined, then we can put on top of it AI. So now we could bring AI to 5G and 6G. Parabricks for genomics analysis, Monai for medical imaging, Earth-2 for weather prediction, cuQuantum for quantum classical computer architectures and computer systems, cuequivariance and cuTensor, contraction of tensor mathematics, Megatron. This whole row, this whole column here consists of all of our deep learning and all of our libraries necessary for training as well as inference for deep learning. This revolutionized computing. And it all started with all these libraries. Not just CUDA, but cuDNN. On top of cuDNN, there was Megatron, then TensorRT LLM, and then now lately, this brand new operating system for large AI factories, Dynamo. cuDF for data frames like Spark and
cuDF.
SQL. Structured data can be accelerated as well. cuML, classical machine learning. Warp,
This is a
framework
class of
for
the quantum
a Pythonic framework for
graphic card.
describing CUDA kernels.
If you are doing
Incredibly
this, meaning that you
successful.
already do the AI stuff
Mathematical operations, optimizations, things like traveling salesperson, the ability to optimize highly constrained, large number of variables, type of problems like supply chain optimization. This is an incredible success. I'm very excited about cuOpt, cuDSS and cuSparse for sparse structure simulators. Those are used for CAE and CAD, fluid dynamics, finite element analysis, incredibly important for EDAs and CAE industry. And then, of course,
What the-
cuLitho, one of the most important libraries for computational lithography. Mask making could easily take a month. And that mask making process
I just
is
tried 70
extremely
VM mode and it's
computationally intensive.
working here.
And now with cuLitho,
Okay.
we can,
I think that's good.
accelerate that computation by 50 times, 70 times. As a result, this is going to set the stage, open the world for applying AI to lithography in the future. We have great partners here. TSMC is using cuLitho quite extensively. ASML, Synopsys, excellent partners working with us in cuLitho. So the libraries themselves is what makes it possible for us one domain of application after another domain of science, after another
This
domain
is like
of
a
physics,
top
to be
level
able
of the
to
AI, right?
accelerate
They are
those
talking about the
applications.
hardware,
But it also opens
where
up
the hardware can do
markets
many
for us.
things for
we look
the
at
AI.
particular regions and particular
But
markets,
what
and
we
we
are
say
doing
that
in the
area could
Asia
really be
Southeast
important to
It's
transform
just
to
like
the new way of
using
doing
the
computing.
AI from
If general purpose
ChatGPT
computing, after
to
all these
generate
years,
some
has run its course,
document
why
or
hasn't it
maybe
run its
generate
course in
some
every
of the
single
code
industry?
to help with you.
So one of the most important
But
industries, of course, is
people
telecommunications. Just
Asia,
as the world's
they
cloud data
claim
centers
that
have now
they already
become
know the
software
AI.
defined,
They
it
know
stands to reason
everything.
that
AI is
telecommunications
future,
should
but they
also
did
be
not
software
know
defined.
that there's so
And
many
that's the
things
reason
that
why
AI
we've
can
taken
do
now
here.
some
Like
6 years to refine.
let me just scroll back. You know, right? In the behind, they has so many things going on. CUDF, CUML, RAP, CUOPT, CUDSS, CULITO. Everything's like that. We never know, right? What they do, what they are doing. They are how to say they are very deep into this AI. While we in the Asia like this, we use it for the generate. I mean, there are some social influencer like claiming that they know about AI or something, they can generate something. That's AI that you use is the output that because they do some deep learning and some many
software defined
infrastructure that is going
so
on.
Cisco are working on the systems, and so
This
now
is-
we have the ability
I think this is
to
the more true AI that
introduce
they are building right
the
now.
idea of AI on 5G or AI on 6G.
If you want to more into
along
the
with,
AI and know about
AI on
everything, I
computing.
think you should tap on this
We're doing
part
that with quantum computing.
instead of
Quantum
just
computing is still
generating a document
at
or
the
maybe generating
noisy,
something in the
intermediate
code
state,
and then
intermediate scale
you know
quantum
everything
called
about
NISQ.
that.
However, there are many, many good applications
And
we
this
could
is a
already start
computer
to do.
quantum,
And so we're excited
CUDA
about that.
Q.
We're working on a quantum classical or quantum GPU computing platform. We call it CUDA Q, working with amazing companies around the world. GPUs could be used for pre-processing and post-processing, for error correction, for control. And so in the future,
Then who is
I
going
predict
to
that
buy
all
this quantum
supercomputers
computer?
will
you know?
have quantum
The
accelerators.
price
all
is
have
even
quantum QPUs connected to it.
$10,000,
And so
I
a
can say,
supercomputer would be a
or more.
QPU with QPUs and GPUs
But
and
in
some
terms
CPUs.
of generating
And
a
that would be
prompt,
the
like you
representation
asking
of a modern
ChatGPT
computer.
or something like that,
So
they
working
will
with a lot
respond
of
very
great companies
fast.
in this area. AI.
It's just very
12
expensive.
years ago, we
if you
started with
want to
perception.
more into
AI
the
models
AI.
that can understand patterns, recognize speech, recognize images. That was the beginning. The last 5 years, we've been talking about generative AI, the ability for AI to not just understand, but to generate. And so it could generate from text to text. We use that all the time in ChatGPT. Text to images, text to video,
Yes.
video to text, images to text. Almost anything to anything, which is the really amazing thing about AI, that we've discovered a universal function approximator, a universal translator. It can translate from anything to anything else if we can simply tokenize it, represent the bits of information. Well,
Yes.
now we have reached a level of AI that's really important. Generative AI gave us one-shot AI. You give it text, and it gives you text back.
Yes.
That was 2 years ago when we first engaged ChatGPT.
Currently,
That
the
was
generative AI is
amazing
only what they
breakthrough.
do is
You give it
I
text,
ask
and it gives you
something,
text back.
they ask
It
me
predicts
back.
the next word,
There
predicts
is
the
some
next verb.
input, they will give me
However,
the output.
Intelligence is much more
But
than
now
just what
we
you've
are on the
learned
edge where
from a lot of data
agentic
that you
AI
study.
is going on.
Intelligence
I think he
includes
will
the
explain
ability
it
to reason,
near
to be able to solve problems
near
that you've
this
not
part.
seen before, to break it down step by step, to maybe apply some rules and theorems to solve a problem you've never seen, to be able to simulate multiple options and weigh its benefits.
Twitch, let me just check it to
Some of the
just
technology you
chatting
might have heard about,
category.
chain of thought, breaking it down step by step, tree of thought, coming up with a whole bunch of
In
paths.
real life, just
All
chatting
of these technologies
category.
are
I think
leading
that should be enough.
the ability for AI to be able to reason. Now, the amazing thing is, once you have the ability to reason, and you have the ability to perceive, that is, let's say, multimodal read PDFs, you could do search, you can use tools, you have now agentic AI.
I
This
think the
agentic
next
AI
future is all about
just
agentic
does
AI,
something
you know.
that I
Agentic
just
AI
described
is-
all of us do.
I think they
We
are
we're
more
given a
interesting
goal,
to tap
we
on
break it down step
to
by step,
check
we reason
this
about what
AI,
to do,
but
what's
it
the
will be
best way
more
to do it.
expensive because
We consider its
generative
consequences,
AI right
and then
now
we start
currently you
executing
need
the
to pay
plan.
$20
The
per
plan might
month.
include doing some research,
ChatGPT
might include doing some work,
company
using some
charge
tools.
you.
It might include
But
reaching out to another
I don't know
AI
about
agent to
agentic
collaborate
AI.
with it. Agentic AI is basically understand, think, and act. Well, understand, think, and act is the robotics loop. Agentic AI is basically a robot in a digital form. These are going to be really important in the coming years. We're seeing enormous progress in this area. The next wave, beyond that, is physical AI.
Yes,
AI
physical
that
AI.
understands
the next is physical
world.
AI.
They understand things like inertia.
So they are
Friction,
timeline, right?
cause
First
and
is
effect.
generative AI.
That if I
then going
If I
on
roll
is
a ball
agentic
and it goes
AI.
under a car, depending on the speed
Then
of the
the
ball,
next is
it probably
physical
went
AI.
to the other side of the car.
But
the ball
physical,
did
it will
not
be like
disappear. Object permanence.
Terminator, right?
You might
The
be able to
robot
reason
can do
that
anything,
if there's a
can
table
perceive,
in front of you
reasoning,
and you have to go, you
and
have to
can
go
do
to
some
the other
decision
side.
making.
The best way to do it is not to go right through it. The best way is maybe go around it or underneath
I
it.
think some people on
To
the
be able
top
to reason about these
company
physical things
or
is
maybe
really
top
essential
position will
to
use
the next era of AI.
this AI to
We
do
call that
some
physical AI. And so in this
decision
particular case,
making.
you're seeing us simply prompt the AI, and it generates videos to train a self-driving car in different scenarios, and I'll show you more of that later.
It's like Tesla self-driving
That's
car.
a dog. So generate me a dog, generate me one with a bird, with people. And it started out with the image on the left.
Oh.
And then the phase after that, we take reasoning systems, generative systems,
Wow, general robotic.
physical
After
AI.
physical AI is
And
general
this
robotic.
level of capability
Oh,
would
that's
now
a new
go
age.
into a physical embodiment. We call it a robot. If you could imagine that you can prompt an AI to generate a video to reach and pick up a bottle, of course you could imagine telling a
Gila, kalau
robot
ada
to reach
Gojek
out
kan
and pick up
bisa
the bottle.
ngambil beli barang.
The AI
Kalau ada
capability
robot
today
mau
has the
ngambil
ability to do
minum
those
tinggal
things.
minta aja udah.
Well, the computer that's
Mau duduk
where
minta
we're going
bantuan
in the near
duduk.
future. The computer that we're building to make this
Wow.
possible has properties that are very different than the previous. The revolutionary computer called Hopper came into the world about 3 years ago, and it revolutionized AI as we know it. It became probably the most popular, most well-known computer in the world. In the last several years, we've been working on a new computer to make it possible for us to do inference time scaling, or basically thinking incredibly fast. Because when you think, you're generating a lot of tokens in your head, if you will. You're generating a lot of thoughts, and you iterate in your brain before you produce the answer. So what used to be one-shot AI is now going to be thinking AI,
Thinking
reasoning
AI,
AI,
reasoning.
inference time scaling AI. And that's going to take a
Kalau
lot
AI itu
more
gini sih,
computation. And so we created
Reasoningnya yang penting
a
sih.
new system
Ada
called Grace
bagian
Blackwell.
dari there's a part in
Grace
the
Blackwell
reasoning with the
does
AI.
several things.
That part is
It has the
you need
ability
to
to
tweak a
scale
little
up.
bit. That
Scale
is
up
quite
means to
challenging.
turn what is
That's
a
what I know
computer
from
into a
AI.
giant computer.
But the rest of
Scale
it,
out
if you want to
is
develop
take
in
a
the
computer
AI, you
and
need to
connect many
pay
of them together and
a
let the
some
work be
amount
done
of
in many
money
different
lah.
computers.
You need to
Scaling
pay for the
out
token.
is
The token
easy.
is not free
Scaling
actually.
up is incredibly hard. Building larger computers that is beyond the limits of semiconductor physics is insanely hard. And that's what Grace Blackwell does. Grace Blackwell broke just about everything. And all of you in the audience, many of you are partnering with us to build Grace Blackwell systems. I'm so happy to say that we're in full production, but we can also say it was incredibly challenging. Although the Blackwell system based on HGX has been in full production since the end
Let
of
me
last
change
year
the Twitch
and has been
title
available
first.
since February.
I
We are
think
now
I'm-
just putting
I haven't
online
going to
all the
pull for
Grace
Anaxagoras
Blackwell
yet,
systems.
but that's
They're coming
okay.
online all over the place every single day.
As for
It's available
YouTube,
in
I
core
think
read
I
now
will
for
just
several
shut
weeks.
down a
It's
bit,
already
so
being
it
used by
will
many
not
CSPs.